Hi, so the essential objective of this lesson is to understand the vectors concept for international mathematics or extended mathematics course. So first thing is that we're going to understand the vector presentation, what you mean by a vector, what exactly is the understanding of the basic concept of presentation. Magnitude of vector, we're going to talk about it, and then we're going to talk a little bit about vector geometry in context of the problem solving. Now, first thing is that when you're talking about a vector, now first important thing is a vector is something that is different compared to scalar in terms of its requirement to express completely, require direction, and you require magnitude. So when you require direction and magnitude both, we call a quantity to be a vector quantity. Now, when you're talking about first thing is what is a position vector? Now, if you're at a certain point away from the origin, we term this as position vector O to A, and it is represented as vector OA. Now, position vector of A is the vector joining origin to that point. The arrowhead represents the direction. Now, if you're talking about, let's say, vector joining 2 points, now if I have got a point A, I've got a point B, and I wanted to find out a vector joining these 2 points, I'm going to show like this. And it is represented as vector A to B. Vector AB is the vector that I'm looking forward to. Now, if I had the coordinate of A as, let's say, 1, 7, and coordinate of B as 3, 5, I can find out vector AB as the coordinate of B minus coordinate of A. So position of B, which is final position of B, position of B minus position of A, that's your vector. That's what is all about, because vector just depends on initial and final position. So this is how you kind of find out the position vector. So now vector is actually, if you have vector OA, I can write down this in form of, if a coordinate is, let's say, 3, 7, for a point, I can write down this as 3 and 7. So I'm going to go 3 to the right and 7 units up. 3 to the right and 7 up. So that's how I write down in column form. So position vector of B is basically 1 and 7. So 1 and 7 minus position vector of A. Position vector of B is 3 and 5 minus 1 and 7, let's say. That's going to be 2 and negative 2. So this is 2 units to the right you're going to go. So let's say if my points are presented correctly, the 1, 7 is somewhere here, and 3, 5 is here. So I'm going to go 2 to the right and 2 units down in order to reach to that point B. So if I would have drawn a proper diagram, this is how it's going to be. So now when you have been given, let's say, a point A as, let's say, 5, negative 3, B as 2, 7, and C as 8, 5. Let's say you have been asked to find out, let's say, vector AB, vector BC, and vector CA, or vector AC. So vector AB is basically final coordinate of B minus initial, so 2, 7 minus 5 and minus 3. That's going to be my AB, which is going to be 2 minus 5, which is negative 3, and 7 minus 3, which is 10. That's the vector AB. To find vector BC, you're going to just do B to C. Vector BC is basically 2 minus 8. Vector BC is 2 minus 8. So coordinate of 8, B, coordinate of C is 8 and 5, minus coordinate of B, which is 2 and 7. That's going to be 6 and minus 2. So that's the coordinate of, that's the vector BC. To find out vector CA, you're going to do final position is A. So A is 5 and negative 3 minus the coordinate of C is 8 and 5. So that's going to be minus 3 and minus 8. So that's a vector C. So now this is the way you calculate the vectors joining 2 points. Now let us talk about the second quantity that's called as magnitude of a vector. Now, if I present a vector, let's say in column form, as vector A is, let's say small vector A is X and Y. So vector A is, let's say X units to the right and Y units up. If I go, this particular length is the vector A, this particular vector is A. And if I do the magnitude of this, magnitude is represented by these two vertical bars, and it is X squared plus Y squared root by Pythagoras theorem. So if my vector is, let's say, -3 and 10, if I write on magnitude of AB, it is going to be -3 and -3 squared plus 10 squared and root of this. That's the magnitude of AB, because it's simply Pythagoras theorem application. Now, when you're finding out, let's say, questions like in exam, this is the exam style question that I'm doing. Let's say vector A is 1, -1, vector B is 2 and 5, and vector C is 1 and -3. And I want to find out firstly, it's the magnitude of A. Now to get the magnitude of, we can try this. This is going to be 1 squared plus -1 squared, which is root of 2. If I'm asked to calculate magnitude of A plus 2B, that's going to be A, first you find out vector A plus 2B. So A plus 2B is going to be 1, -1 plus 2 times B is 2 and 5, which is 1 plus 4 minus 1 plus 10. This is going to be 5 and 9. And magnitude of A plus 2B is going to be 5 squared plus 9 squared and root of this. So that's how you find out the magnitude. So you like first find out this vector A plus 2B, and then find out the magnitude. Similarly, sometimes they say write down the magnitude of, let's say, 3C. The magnitude of 3C is like you multiply this vector by 3. So if you multiply, it becomes 3 and -9. And then you find out the magnitude of this. So it will be 3 squared plus -9 squared. And you can find out it will be 9 plus 81. That's what is the answer. So this is about the magnitude. One of the standard example that keep coming in our exams are this kind of question. You can try this like, m times, let's say 2 and -3 plus n times a vector 1 and -5 equals to 6 and 8. You've got to find out the value of m and n. So this is going to become 2m. You can pause before I solve this. 2m and -3m, 2m and -3m, and this becomes plus n minus 5n. So this is basically the simplification, and this is equals to 6 and 8. So 2m plus n equals to 6, and -3m minus 5n equals to 8. Now, if you solve this simultaneous equation, like for example, if I multiply this equation by 3, multiply this equation by 2, and so what you're going to get is basically, let's say this is going to be 6m plus 3n. You're going to get the answer for this particular question. So get 6m plus 3n equals to 18, and you get -6m minus 10n equals to 16. You add these two, you get the answer. So it's going to be -7n equals to, this is 8 plus 6 is, this is 34. So -7n is 34. And so you get n is 34 over -7. So you get the answer for n. Similarly, you can plug in one of this and you can solve for m as well to get the exact answer. Going towards, let's say now, vector geometry. So while you're doing a question on vector geometry, I just would like to take a particular question from our exam paper, which is basically this question. Now, before I go to this, I would like to tell you a little bit about the vector geometry rules. Now, when you're talking about vector geometry, remember that, let's say if I consider the triangle OA and B. Now, if I'm being given that, okay, this is the position vector of A is A, position vector of B is B, and you've been asked to find out vector AB. Now, vector AB is going to be -A and plus B. Vector AB is negative A plus B. That's a vector AB. Now, if I have been asked to go from, let's say, there is a midpoint M, and I've been asked to go from O to M, and what is that vector? So O to M, if I go on, it will be O to M, vector OM is, I can go from O to A, and then I can come from here. So O to A, and then half of AB. So O to A is nothing but A plus half of AB, which is negative A plus B. And if you simplify, it'll be A minus half A plus B by 2. And you're going to get the answer basically as A by 2 plus B by 2. This is just like a recap of the vector geometry. And now let us try a particular question that has been like assessed in your exam. So this is the question on your screen that you can see. We may just like pause a little bit and try this question. And then you can check the answer from my booking. All right, so here, if you see in this question, you've been given OABC is a parallelogram. So from parallelogram, and OPQ is on a straight line. P divides AC in a ratio of 1:2. So this part is, if I take this as 1, this, if I take it as 1, this is 2 parts. And P divides OQ in a ratio of 1:2 again. So this is 1 part and this is 2 part. What we have to do is we have to find out in terms of A and C, A and or C, the vector AC. And when you're finding vector AC, now first part is, let's say it's pretty similar to what I did as the beginning of this. When you're finding vector AC, I can go from A to O, vector A to O plus vector O to C. AC is, I will go from A to O and then O to C. And that's how I get vector AC. So vector AC is negative of A and plus C. That's your vector AC. Now I'm talking about OP. Now, how do we get vector O to P? Now, see, O to P is basically, you have been given that vector O to P is O to A plus A to P, A to P. So I can go from O to A, which is basically, that is this way. I'll just redraw it. To go from OP, I'll go from O to A and then A to P. And you know that O to A is A and A to P is actually 1/3 of AC, because A to P is in the same direction as AC, and but it is like, this is 1 part, this is 2 parts. So in total, there are 3 parts. The fraction of AP with respect to AC is 1/3. Okay, so now when you're going to take this as A plus 1/3 of AC, which is negative A plus C, which is A minus 1/3 A plus 1/3 C, which is going to be 2/3 A and plus 1/3 C. So basically we get OP as 2/3 of A and 1/3 of C. Now to get CQ, which is vector C to Q from here to here. So it's vector C to Q actually will be vector C to O. I can go vector C to O and plus O to Q. So now this is very interesting. So C to O we already know is vector negative C. This is negative C, and O to Q. I don't know the vector exactly, but I know OP. This is 1 and this is 2 parts. So if 1 part is corresponding to this one, which is OP, now total of, there are 3 parts like this. So this, if I triple it, like OP, if I triple, OP, if I triple, I get OQ. Because if you simply see, this divides P is in ratio. They have said that clearly, that P divides OQ in a ratio of 1:2. So if this is 1 part, this is 2 part. In total, there are 3 parts. Okay. So OP is basically 1/3 of the big length, which is OQ. So if I do 3 times this, you're going to get 2A plus C. And so this get canceled and you get 2A. as simply the answer. Because if you do triple of this, you're going to cancel this 3 and 3. You get 2a plus c as the OQ. And now we're getting to the final part. Tell what can be said as C, B, and Q. So C, B, and Q. So look, if I look at C, B is just A, and C, B, Q is 2 times A. So you can clearly see that C, B, Q, firstly, they fall on the same line. Also, the length CQ is 2 times length CB. So this is what you can exactly say about this particular problem. You may try this question properly, make sure that you understand this because this is one of a good exam question. Just as a summary of what we get from this problem, you should understand that, let's say if you got A, B, and C as 3 points along a line, if I've been given, let's say, vector AB, like randomly, this is not related to this problem. If I've given, let's say, AB is, let's say, vector A plus B, and I've given vector AC is, let's say, 3 times A plus 3 times B. Firstly, you can see that if the vectors are scalar multiple, then you can say that those vectors are in the same direction. If you can see that this is 3 times AB, it means that they're on the same line as well because of the starting point. So this is how you talk about in terms of such question when they have given. Let's take another example, which is not in from vector geometry, but I'll take some more questions on vector geometry after this. It has been given that vector P is 2 and negative 1, Q is 3 and 2. Write down the vector Q minus P. So Q is 3 and 2, minus P is 2 and negative 1. That's going to be 1 and 3. That's your vector Q minus P. Now 2 times P. Now 2 times P is going to be 2 times P is 2 and negative 1, which is 4 and negative 2. On a magnitude of 2p, which is going to be 4 squared plus negative 2 squared root of this. And that's your answer, which is kind of root 16 plus 4, which is root of basically 20. It has been given that point A is 0, 2 and B is 2, 7. Write down AB as a column vector. So as I've told you here, AB is basically position vector of B, which is 2 and 7, minus position vector of A, which is 0 and 2, which is going to be 2 and 5. That's a vector. They have given BC is 2 times AB. So BC is nothing but, they have given coordinate of C. So if I take coordinate of C as X and Y, position vector of C, so it'll be X and Y, which is final coordinate of C minus initial coordinate of B, which is, we have got the B, which is 2 and 7. This should have been equals to 2 times AB, which is 2 and 5. So which is 4 and 10 basically. So you can equate now. From here, you can say X minus 2 equals to 4, which gives us X as 6, and Y minus 7 equals to 10, which gives us Y as 17. So this is how you do this tiny bit of question. Here's one more problem on vector geometry. This is an interesting question. They have given us that vector O to A is, this is 6A, and they have given O to C, that is 6C. They have also given that AB and BC ratio, AB with BC ratio, this ratio is basically 1 and 2, and OD and DC ratio is also 1 and 2. The lines OB and AD intersect at X, they have given this. What you have to do is you have to find out in terms of A and or C, AC. It's pretty easy. If you look at A to C, I'm going to go negative 6A because against this, and I'm going to go plus 6C. So negative 6A plus 6C, that's your vector AC. Go to vector B to C. Now, since you know that B to C is two-third of AC. Now, vector BC is two-third of AC, so the two-third of AC is nothing but negative 6A plus 6B, 6B, which is nothing but, if you simplify, take 3 common and divide it, so it'll become negative 4A plus 4C. Now, next part is write down vector BD, B to D in terms of A and or C. Now, to go from vector B to D, I can go from B to C and then C to D. So, vector B to C, B to D is vector BC plus vector CD. And vector BC we just got is negative 4A plus 4C. And vector BD, vector CD that we have, since this is 1:2, if this total is 6 parts, so if I just basically find out how much is this DC corresponding to, you can easily find out that this answer, if you see OD with DC, is basically they have given as a 1/2. So since I have been given, um, let's say in short, what happens is like O to C, DC is basically DC is basically 2/3 of O to C. So 2/3 of O to C, if you do, you're gonna get DC. So 2/3 of, now OC is 2/3 of, OC is nothing but 6C. So this is gonna be 4 times C. So this is 4C. Now, we get the vector BD. Now, we already have got BC here. And now to get C to D. So C to D is going to be against 4C. So 4C is that this is going to get canceled and you get negative 4A. So this vector B to C that you got is basically B to D is negative 4A. So here, this is what is the context. So let's say if they ask us to find out what can you write down or what can you tell about BD and AO. You can clearly see that this is a like negative 4 times A and this is 6 times A. So they are basically like, scalar multiple. You can see that one is going in this direction, other is going in the other direction, minus 4A. So minus 4A, you can see is a scalar multiple of 6A by, you can say, negative 2/3. Okay. So you can see that they are parallel vectors, anti-parallel, you can use the word, and their magnitudes are, you can say, AO is 3 by 2 times BD, you can say, or BD is 2/3 times AO. So these are kind of questions like, you might keep getting in the exams, and I hope you're prepared for these questions now.